Hello everyone, hope you are all doing well. I am Vichit Kumar. Today in this video we are going to learn how to find hybridization in the easy way. So for that we are using one simple trick known as steric number method. Steric number is the sum of number of sigma bonds and number of lone pairs around the central atom. So I can write steric number that will be represented as Sn will be equal to number of sigma bonds plus number of lone pairs around the central atom. So now let us list out steric number and their corresponding hybridization and geometry. If the steric number is 2, then the hybridization is sp, then the geometry will be linear. If the steric number is 3, then the hybridization is sp2 and the geometry is trigonal planar. If the steric number is 4, then the hybridization is sp3 and the geometry will be tetrahedral. If the steric number is 5, then the hybridization will be sp3d. Then the geometry will be trigonal bipyramidal, which is also represented as TBP in short. So, trigonal bipyramidal. In short, we can write TBP. If the steric number is 6, then the hybridization is sp3d2. In this case, the geometry will be octahedral. Octahedral. If the steric number is 7, then the hybridization is sp3d3. In this case, the geometry will be pentagonal bipyramidal. Pentagonal bipyramidal. In short, which is also represented as PBP. Okay, here in case of sp3d and sp3d2 and sp3d3, we should remember which d orbitals is undergoing hybridization. So I will write in case of sp3d, here the d orbital which is undergoing hybridization is dz square. In case of sp3d2, the d orbitals which is undergoing hybridization is dx square minus y square and dz square. In the same way, in case of sp3d3, the d orbitals which is undergoing hybridizations are dxy, dx square minus y square and dz square. Here is a note, when there is no lone pairs on the central atom, in that case, so no lone pairs, okay, lone pairs will be equal to 0. On that case, steric number will be equal to number of sigma bonds by using that formula. Okay, what it means? In this case, the shape and geometry of the molecule will be same. Shape and geometry. Shape and geometry will be same for the molecule. So what does this shape and geometry means? While speaking about shape of the molecule, we only consider spatial arrangement of bond pairs. While speaking about geometry of the molecule or structure of the molecule, we will consider both lone pairs and bond pairs around the central atom. This is the main difference between shape and geometry of the molecule. In order to understand this trick clearly, let us consider few examples. So the first example is methane molecule. In case of methane molecule, the central atom is carbon and 4 hydrogen atoms are known as terminal atoms. The central atom is carbon, valence electron will be equal to 4. What is the number of sigma bonds in this molecule? We should just see the terminal atoms. Here 4 hydrogen atoms are there which are terminal atoms. So 4 sigma bonds will be formed. What is the number of lone pairs? Here there is no lone pairs, 0. Why? The valence electrons which are present in this molecule of the central atom is 4 and already 4 sigma bonds are formed. So there is no lone pairs in the central atom. So steric number will be equal to 0 plus 4, which is nothing but 4. So what is the hybridization here? sp3. The geometry will be tetrahedral. Geometry will be tetrahedral. The second example is ammonia. Here the central atom is nitrogen. Valence electrons are 5 for nitrogen. How many sigma bonds are present? 3, right? Because 3 terminal hydrogen atoms are present. How many lone pairs are present? Since valence electron is 5, already 3 sigma bonds are present. So remaining is 2, right? 1 lone pairs. Now let us calculate steric number. Steric number will be equal to number of sigma bonds plus number of lone pairs, which is nothing but 4. So the hybridization will be sp3 and the geometry will be tetrahedral. In this case also the geometry will be tetrahedral. So let us consider few more examples. The third example is BF3 molecule. In case of BF3 molecule, the central atom is boron. So valence electron will be equal to 3. What is the number of sigma bonds around central atom? It is 3, right? Because terminal atoms, that is nothing but fluoride atoms, are 3. So 3 sigma bonds. Is there any lone pairs? There is no lone pairs because 3 valence electrons are there and already 3 sigma bonds are present. 3 minus 3 is 0. So there is no lone pairs around the central atom. So steric number will be equal to 3 plus 0, which is nothing but 3. So the hybridization is sp2 and the geometry will be trigonal planar. Correct? Geometry will be trigonal planar. Let us move on to next question, that is ammonium molecule. So in case of ammonium molecule, the central atom is nitrogen. So valence electron will be equal to 5. Since the molecule is having plus 1 charge, correct? If there is any positive charge, we should subtract those charges from valence electron of the central atom. So 5 minus 1, that is nothing but 4. How many sigma bonds are there? Total 4 hydrogen atoms are there. So 4 sigma bonds is present in this molecule. So sigma bonds is nothing but terminal atoms. So how many numbers of lone pairs of electrons are present? Is there any lone pairs? No, right? Because valence electrons will be 4 and already 4 sigma bonds are present. So there is no lone pairs. So steric number will be equal to 4 plus 0, which is nothing but 4. So the hybridization is sp3 and the geometry will be tetrahedral. Correct? So now let us move on to the next problem. In XeF4, the central atom is xenon and the valence electrons in the xenon is 8. Why? This belongs to inert gas, right? Inert gas group. So outermost valence electrons are 8. Is there any sigma bonds? Yes. How many? 4, right? Because 4 terminal fluoride atoms are present. Is there any lone pairs? There are lone pairs. How many? 8 minus 4. That is nothing but 4 lone pairs of electrons. How many lone pairs? 2 electrons constitute 1 pair. So there are 2 lone pairs of electron. Okay. Now let us calculate steric number, which is nothing but 4 plus 2, so 6. What is the hybridization then? sp3 d2. So the geometry will be octahedral, correct? So I can represent these two lone pairs like this. Okay. So let us move on to the next problem. The next example is water molecule. In water molecule, oxygen is a central atom and valence electrons of oxygen is 6. How many sigma bonds are present? 2, right? Because 2 terminal hydrogen atoms are present. Is there any lone pairs? Yes, there are 2 lone pairs. Why? 6 minus 2 is equal to 4. That means 2 pairs of electron. And steric number will be equal to 2 plus 2, which is nothing but 4. So the hybridization is sp3 and the geometry will be tetrahedral. Correct? So let us move on to the next example. In SF4, the central atom is sulfur. Valence electrons in sulfur is how many? 6. Why? Because sulfur belongs to oxygen family. So valence electrons in sulfur is 6. How many sigma bonds are present? 4, right? Is there any lone pairs of electron? Yes. How many? One lone pair. Correct? One lone pair is present. So steric number is 4 plus 1, which is nothing but 5. So the hybridization is sp3d. So what is the geometry? Trigonal bipyramidal. Correct. Trigonal bipyramidal. Trigonal bipyramidal is the geometry of SF4 molecule. Here I can represent lone pairs above oxygen in case of water molecule, and in SF4 also I can represent the lone pairs like this. Okay, so let us move on to the next example, that is xenon difluoride. Here the central atom is xenon, so valence electron will be equal to 8. How many sigma bonds are present? 2. That means how many lone pairs will be present? 8 minus 2 is 6. That means 3 pairs of electrons are present as a lone pairs. So the steric number will be equal to 2 plus 3, which is nothing but 5, and the hybridization will be sp3d, and the structure will be trigonal bipyramidal. Correct? Trigonal bipyramidal will be the geometry or structure of the molecule. Let us consider few more examples. The next example is I3 minus. I can write I3 minus as I2 minus. I will consider one of the I as central atom. So valence electron will be equal to 7 in case of iodide. Why? Because it belongs to halogen family. And is there any sigma bonds? Yes, there are 2 sigma bonds. Here there is a negative charge on the molecule. So whenever there is a positive charge, we should subtract those charges from the valence electron. Whenever there is a negative charge, we should add those charges to the valence electron. So there is minus 1 charge, so I should add plus 1 to the valence electron. So the sum will be 8. So now let us calculate lone pairs. Is there any lone pairs? Yes, there are lone pairs. 8 minus 2, which is nothing but 6. That means 3 lone pairs are present. So steric number will be equal to 2 plus 3, which is nothing but 5. The hybridization will be sp3d, and the geometry will be trigonal bipyramidal. Okay, the last example is XeOF4. Here the central atom is xenon. Valence electron in xenon is 8. Total there are 5 sigma bonds, 4 from fluorine and 1 from oxygen. And there are how many lone pairs are present? 8 minus 5 means 3, and there are 1 lone pair means 2 electrons. So 1 lone pair is possible. For understanding, let us roughly draw one molecular structure. Xenon bonded with fluorine atoms, and 1 oxygen atoms, and 1 lone pair is present. This is the rough structure of xenon oxytetrafluoride. Okay, so now we can understand the 8th electron is in the pi bond, correct? The 8th electron, here one sigma bond is the second sigma bond, third, fourth, and one more sigma bond is there with the oxygen, and another bond is known as pi bond, and one more electron, that is nothing but 8th electron of xenon, is present in between oxygen and xenon in the pi bond. Okay, so now let us calculate steric number. Steric number will be equal to 5 plus 1, which is nothing but 6. 6 means which is sp3d2 hybridization. So the structure will be octahedral. Structure will be octahedral. Hereby we come to an end of this video. If you have any doubts, do let me know in the comment section. I will meet you in the next video. Until then, take care. Bye bye.